Hello YouTube, iFixItAll here, Team iFixItAll. Been MIA for a little while. I've been working on building myself a dedicated electronics repair bench and cleaning up the garage, so to speak. But I've got myself a workbench set up here. I need the ESD mat. I'll pick one of those up soon. Have no idea how much that'll cost. ESD mat is this thing right here. Reminds me of masonite, but it's made to be soldered on and things like that. For Navy people, it's a pay station or what have you. But this is just store shelving material with the uprights and the floor brackets. Put me a piece of 2x6 on here. But long and sweet of it is I've got this thing customized out to where I'm satisfied with the overall usefulness of it. I'll just pull a stool up right there. It's at the right height. I can put my feet right there. I've got lighting. I'm working on a few things, but long and sweet of it is I needed electricity and for multiple devices, and what better than to install the workbench is kind of clean right now, except for that end. I got to find a home for several things there, but here's the power strip. This power strip is, well, damn it, what's the purpose of the video? The purpose of the video is electricity can trick you sometimes. I'm having a problem. So I'll get there. I just want to show you. It's important that you see what's going on with this power strip. The power strip has a cover on it. It has a bunch of outlets along the bottom where I can conveniently plug all kinds of electronics into, or devices for soldering and what have you. And I've had a few power strips put back and I give them away or whatever. And this is my last one. So I took the cover off. There's a few screws that holds this cover here. Drilled a few holes and I screwed the power strip right into this vertical piece of lumber here. And this is old shelving, you know, a cheap little shelving thing you could get at Walmart or what have you. Here's another piece of the shelving. And to integrate it, I added this heavy-duty wall bracket on each end. And I attached it to the uprights with a couple of self-tapping screws. So the wall bracket is mounted to these metal uprights, and then I had to for deflection purposes, so the top shelf doesn't sag, I added some metal banding material here. And as you can tell, it's under pressure because there's weight up there. So the power strip did not have a proper cord on the end. I built my own proper cord end, but for a while there I was temporarily, I shouldn't have touched it. That's number 10 wire too. Number 10, because I've also updated my welding bench over here. So I can have I've got a power strip tied to the welding bench and plasma cutter, and I can do work right there. And this screen here helps catch debris, and that's an aluminum plate. Back to the power strip, it didn't have a cord on the end, so I was temporarily backfeeding the power strip, so I'll explain that real quick. I was powering up the power strip in a temporary manner. And what that means is that's a power strip over there, and so is this, okay? It's not plugged into anything. And I had to fabric cobble myself a male to male. And this is how you backfeed a power strip. You plug in one end to your source, and that hair dryer is already on. And right now that's off, but that switch has no effect on what I'm about to do because these bus bars here are bonded all the way down the neutral. The wide opening is your neutral always, and your skinny opening is your hot. And if you're holding a 2-wire cord, one edge of the cord will have a rib on it, and that's always going to be your neutral conductor. It has something to do with Americans with Disabilities Act and all that, before they decided to widen the neutral tang. This is the neutral tang. It's wider, and the hot tang is skinnier. So I was backfeeding this power strip here temporarily, and I had it backfed for quite a while, from this outlet, one of these outlets down here, and I'll get past any questions of the land of YouTube. The outlet is correctly wired. 2 red lights means go. Or, I wish those were green, you know, that should be green. But anyway, you saw it. It's wired correctly. And this is jumpered correctly. In other words, neutral is to neutral. I gotta be careful here because that's gonna go hot in my hand while I plug it in. Okay, check this out. Untangle from the bell housing. Let's see if I'm safe to do what I'm about to do. Okay, yes, I am safe. Ask yourself first. That's what they say in the world of AT&T. Does anyone out there have an ask yourself first card? Watch this. Remember, this is like all you nerds out there, okay? I'm not talking to all you regular people, just the nerds. This is a power strip that is screwed to this wood. It is not physically touching this. As a matter of fact, I've got my meter sitting right here. I've got the red lead wedged into a bare metal cap section of this power strip. Let's prove out it's not. There's no continuity. I'm on ohms right now. Ohms. And this, whoa, this is a screw terminal, so it should have continuity. Goes to open circuit. Continuity. Open circuit. I have no continuity from this metal upright to the chassis of the power strip. Took me a little bit, but I'm getting there. A few days ago, it was raining like a bat out of hell, and let's see if I'm zoomed in. I don't think I am. I fixed that already. And I was dinking around prepping in the materials that I was going to choose to use to make this cord, because I wanted to be able to carry a decent amount of current down this, you know, max this thing out just in case I'm running my little wire welder or my plasma cutter. I want to make sure I don't have issues. And my shoes were wet. I was standing right here, and I was touching that, and I was getting shocked while I had this back fed, like so, the way you see it right now. This should be backfed with a 3-pronger, but knowing what I know about electricity, get a couple lamp cords in there, you're good for temporary. Watch this. I'm going to go to volts AC. I've got like 25, 26 volts AC. Where's that coming from? There's nothing plugged in. All the way down the power strip. Oh, by the way, look how much of a geek I am. The factory screw hole to put the cover on this 2x2 channel. The factory screw hole's right there, which is right dead on with an outlet here. So I drilled me a couple of new holes, and I told myself a message in the future. No. Don't do that, because the screw would go right in. It would stand a chance of penetrating this terminal block there, that outlet. I've got 26 volts AC right now from the chassis of this power strip, which is not physically in any way metallically tied to this bench. But I was getting zapped the other day in a bothersome way because of something else. I have this system set up here to where I also have a desktop computer. I'm going to be mounting a monitor from the ceiling. And I've got this UPS here. And I'm going to turn that on. All right. And I'm going to plug it in to the power strip. Now we know you may not know, but UPSs are really dirty as far as power is concerned, depending on the quality of the UPS. So we've got 25 volts. I'm going to plug this in, and as soon as I plug it in, watch the voltage. All right. See, it spiked almost 60, but it's now at 44 volts AC. Okay, so the UPS has a dirty neutral and ground leg. What do I mean by that? Who cares? It's dirty power. People out there who are geeking out over electricity know what I mean. Anyway, it means there's going to be a certain amount of AC alternating current back feeding onto the neutral or the ground leg or both, because of the lack of filtering technology. It's an APC UPS, but it is not really anything high end. So I've got 43 volts AC here. What's even weirder is that when it was raining really bad, my shoes were wet. And they're getting kind of old. But I was leaving some dampness on the ground here too. Let's see if I can duplicate something, because I'm going to pour water on the leg of this. Remember, this metal is not in any way attached to this, because when it was raining really bad, I had 70 volts AC. So let's get my water. And I'm just going to pour a little water right on the stand and see what happens. There's our voltage. Yeah, so depending on how bad things are. I poured water just now. I don't care about the water on my garage floor. But the other day, due to whatever the humidity would have been in the garage, whatever environmental effects was happening underneath this slab that was electrically connecting to the moisture that I was depositing on the floor, was giving me 70 volts. But right there is 61.6 volts AC. I don't, at that time, I did not know my UPS was that dirty. So if I unplug my UPS right now, since the floor is wet also, then I'm down to 32 volts AC. I don't know what's going on with that. So I got to thinking, well, let me unplug everything in the garage in the outlet world to see if I've got an item in the garage here that's back feeding my neutral or ground leg. I unplugged my deep freeze and that other plug cord which powers a power strip, which powers up my vacuum tube radios. I unplugged all these lithium-ion battery charger systems, which I guess now I can just plug everybody back in on your time here on YouTube. And everybody's plugged back in. So now I'm sitting around 32 volts AC. But I was getting electrocuted with like 70 volts on this thing right here. I was just touching it. And I'm going to unplug my back feed for the power strip. Okay. And that nulled my meter out to like 0.3 of a volt. Okay, so whatever it's picking up right now is what we call EMI. I've got fluorescent lights in the garage. Just ambient air. This thing is a big antenna now to the multimeter. It's picking up radiation in the air. Get rid of my back feed cord. I'll plug my new cord in with the meter still plugged in. And we'll get that installed right here. There we go. It's in. That's not permanent. I'm going to dress that in better. I'm safe, you know. I'm like 1.8 volts AC. I don't know why. It's nothing really to write home about. No biggie. For all that matters, I could be looking down the idea that my meter isn't zeroed out, right? Here's my black lead removed, and just me touching it gives me like 0.5 volt, you know? I could do this, or I could do this, touching the black lead, and I touch that screw head. Remove my finger from the screw head. I'll move the black lead close to a fluorescent light. Anyway, it's zeroed out. There's nothing there. So I still have 20-some volts AC with a 2-prong cord. I don't know why. Like I said, I was trying to, I think I've got time to ad-lib a little bit. what I did was I went to all my outlets in the garage. Everywhere something is plugged in. That big long power strip there, I powered it down completely. This big power strip right here, I powered it down and everything, which powered down everything on it. I even unplugged my grinder. I've got a power strip right here that's got my outside, my power supply for my outside wireless router extender. And then I've got a few other devices. I unplugged all those, waiting to see if I can get rid of that 25 to 30 volts. I unplugged this stuff here. I turned off the lights. There was nothing in the garage running except for a deep freeze. I don't like to unplug my deep freezes. Those are 3-prong devices. This deep freeze happens to be running right now. Anyway, I don't know what I just found, but the power strip is not touching any of this metal, yet with a 2-prong installed, I had a transient voltage, and then I added water down there, and the voltage pretty much over doubled. I thought I could troubleshoot this down to what was causing it. And at some point, you just got to say, it was FM. Because right now, I've only got 1.2. It's nothing. So what do you all think? This power strip was being backfed with a 2-prong cord, a neutral and a hot leg. And the power strip was not metallically bonded in any way with the metal workbench. But yet I was getting zapped when I was touching this. The UPS itself was contributing to a lot of the backfeeding going on. Now let's plug that UPS in now and see what happens. I plugged it in, but I powered it off up front. Since there is a 3-prong conductor in the game, it should appear to behave itself a lot better. Alright, so batteries are charging. It'll go through its timer and click, and then go into charge mode for the batteries. Yeah, there we go. So it's still holding really well with no issues. That meter lead's still making good contact, and so is this one. I'm holding right around 1.4 volts AC. I think the only message I have here is that, and I've been dinking with electricity. I'm in my mid-50s now, and I've been dinking with everything from avionics in the Navy to data center stuff my whole life. And I call this kind of a thing here the moments in your life where it takes you years and years before you run across a weird problem. And depending on what your zodiac is, whether or not you can let it go, because I have trouble letting go of problems without solving them. I want to know where the hell that 20-some volts was, 26 volts was coming from. Because that's substantial enough to say it's being produced by something. Well, how is it showing up on my meter? When the only difference is I have a 2-pronger. Could it be that my garage sub panel is fed from my log house And that 20 some volts AC is being backfed to me from the house, and I just never did know about it. I don't know. I've never seen that voltage before. You know, it seems like as much testing as I've done on outlets, I would have went neutral to ground and hot to ground, and I would have saw a couple dozen volts from my neutral to the ground, if that's even a reasonable discussion, because that's not apples to apples. This is what would technically be called an open circuit. There's no continuity from here to there. But the act of me touching this on that damp day, I was getting zapped, and I had like 70 some volts. We know several volts, like 30 some volts, was coming from the UPS, and the remainder is unsolved mystery. All right, guys. 20 some minutes. Chime in. Help me figure out where that 20 some volts came from. I'm going to reduplicate it. Hang tight. So right now we're in normal operating condition. We'll de-energize the power strip. I didn't put an on-off switch in that. I meant to, dang it. And we'll re-energize the power strip with our back feed. What the hell, I'll just plug it in here. This power strip gets power from there. And just so you can see, this power strip is wired properly. So, am I safe to do what I'm about to do? That's unplugged. Power strip is dead. UPS is on. Looking for power. There we go. That's some inrush from the UPS loading down the circuit. Now that jumped up to 80 some volts, but it's leveling out right around 60. On that wet day, where is this damn... And then if I just take the UPS out of the game, where in the hell is that 33 volts coming from? Where is it coming from? This power strip is not metallically bonded to this in any way, shape, or form. This metal case. I even checked to make sure that... Hell, we can do that right now too. Go to ohms. Shouldn't have unplugged that. Let me plug this back in here. Jam it in. There we go. Alright, make sure we get continuity. We're going to go from that screw. Got continuity. Alright, so the red lead is referencing the chassis. I'm going to go into this plug here. And I got the ground leg. I'm sure I'll get continuity. That's what I expect. There we go. Continuity. 0.3. And I'm going to probe the neutral leg. There's some glare. Sorry if I'm glaring it out. And let's go to the hot leg. I'm going to go to a random hot leg here. I checked these already, and there was no signs that any of these neutrals or hots was faulting out against the chassis of this. And right now, while I'm connected to the bench and that red lead, I still have an open circuit. But as soon as I plug in this 2-prong back feed, I've got 32 volts AC. The only reasonable conclusion I can come up with is because I'm doing backfeeding with a 2-pronger, 30-some volts AC is coming to me from my home, the structure of my home somehow. I don't know. All right, guys. Y'all take her easy. See ya.